Hello! Since the last video was really long and uninteresting, I've decided to change up the format a little bit. So, instead of going through every single minor code change, I'll just change a few things and run you guys through how the major components work and what's interesting about them, and you can hopefully see this evolve a little bit faster now. So the first thing I've changed I want to show you is I've added a world now. So instead of everything just jammed inside the game screen, rendering wise and model wise, we are now containing the model inside this world. So this world contains a tile map and then a list of actors and a list of objects. And whenever you add an actor, it makes sure that the actor is also added in the tile map as well as to the list. This means that we can also update all the actors in a more efficient way than looping through the entire map. Now if you look closely, you can see that there's also an add object method. That's because I've added world objects. So let's have a look at these. These are defined by an x and a y value, and a texture and a size x and a size y. And that's also what we give it here in the constructor, and also an array of grid points called tiles. So I think I'll try to explain this using a paint net. Now let's see. The x and y define the bottom left corner of an object. So that could, for example, be here. And the x and y size define how long an object stretches in in-game tiles in these two directions. This is to make sure that the sprite is rendered correctly when we get to that. Now the grid point 2 array contains all the tiles that this object occupies, so that when we go through the map we can get a tile and then get the object that may or may not be on it. But since a tree might cover some tiles but not all inside of this rectangle, we will define what tiles are affected manually, and that's what we do in this grid point. The grid points are just a coordinate set, so we may have a grid point here and a grid point here, here and here. Let's make one for housing. Actually, now this could be one for housing. These coordinates are relative to the x and y coordinate, by the way. So now we have allowed this sprite to extend over the tiles that are affected, so that this up here, the player can actually walk behind, and the sprite will overlap in a nice way. Let's see if there's something more to this. It can be walkable or not walkable with these. That's what these are for. So maybe I shouldn't. Maybe we shouldn't be able to make a walkable object that has grid points. That would be stupid. Consideration for next version, I guess. Yeah, the tiles can have objects as well as actors, and we just set these objects like we do with the actors, so that when an object is added, all the grid points it has gets added. That gets that object added. Those are weird sentences. I've also gone ahead and gotten all of the rendering code out of game screen. It now resides in world renderer. So because we now have this world that contains our entire model for the game, we can just pass that model to a renderer, and it'll have all the information needed to render it. So when I make this world renderer, I just give it the asset manager and the world I want it to render. And then when we actually get to rendering, I can say what batch I want to render it on and from what perspective I want to view the world. This rendering is a little bit more complicated than the game screen was, because we have this sorting. Now, if the player walks behind the roof of the house, it might put our player in the front, because the map is rendered in this fashion here, from the bottom and up. So to make sure that everything is rendered correctly, we now maintain this for rendering list of Y sortables. And a Y sortable is just an interface defining something like a sprite that can be rendered in our world. And then they are sorted using this comparator that'll just compare the Y coordinate of the world, of the let's see if I can find it here, of the logical X and Y values for both actors and world objects. So you can see the renderer here works its way through the tile map, and then it goes through again, collecting all of these actors and objects, putting them in the for rendering list. Now, since objects are referenced several times in the map, we gotta make sure that the same object is not rendered twice, and that's what this rendered objects is for. So whenever a world object is sent off to the renderer, we also put it in the rendered objects with the hash code, and when we discover a new object, we check whether or not this one has already been added to the for rendering. This could have also, I realize now this could have been done in a better way. Yes, so we sort the list, and then we draw each sortable in the world. Now, let's see. Oh, I fixed a small bug right here, where this finish move is setting the world coordinates to the destination. I did that in a video twice now because it was causing trouble, but since if we're walking more than one tile and then this interpolation function ends up a little bit past the destination, this finish move would make sure that we get reset back to where we're supposed to be. But when walking many tiles at a time, that would mean that every time we move one step, we get aligned to the grid there. And this may not seem like a huge deal. This may actually seem like what we want, but at low frame rates, I realized this gets really choppy, and the player gets teleported back all the time. So now we still take the leftover time here, and we, instead of removing it from the walk timer, we still have it added here to the walk timer, and we instead, after the finish move, add it back to the animation timer, and we, as we move forward, and then the new X and Y are calculated based on how far over our destination we got in the move. Yes, so let's see everything in action here. You can see the fruits of my labor. We now have a nice house. I've only added the house to test these objects, so that's the only thing we have. But we can see that the Y ordering is working. So the house is drawn in front of the player, even though the player has a higher Y value. Thank you for watching my video.